folks. Let's give it a couple more minutes.
Morning.
Let's get started. Thanks for attending this month's TS meeting. As a reminder, if you haven't already, please alter your name in Zoom to reflect the company that you're participating from. That helps me record that in the notes. The way that you can do that is if you hover over your name or the little icon that has your screen, click the three dots and then click the rename button. You can then go in there and put in parentheses the company that you're from, or if you're unaffiliated, just put unaffiliated. Okay. All right, so let's get started. We have two items on the agenda today. The first one will be the Provenca Presto connector. Derek Moore and colleagues will be presenting that. And then after that, we have Costin from Facebook discussing a proposal to change how we build Presto and to separate connectors into different repositories and build them separately to speed up the build and to organize the project better. So let's get started with the first item, which will be the Provenca Presto connector. Are any folks from Provenca on the line and would like to present?
Yeah, sure. I can, I guess, kick this off with an intro to Provenca.
Okay, sounds good.
All right.
I'll stop sharing my screen.
Great. Okay, I think you should be able to see my screen.
I see it.
Sure. So let's just, I guess, dig into what is Provenca at a high level. Provenca is a horizontally scaled storage system with the concept of a stream as the fundamental storage primitive. So a stream is kind of like a file opened in append mode, but writes can be sharded across regions of a routing key space. These regions we call segments. And writes can be ordered or unordered. So writes can specify a routing key to deterministically identify a segment, or writes can be unkeyed and assigned to segments at random. Very similar, I guess, to other horizontally scalable message systems. A stream kind of looks like this in Provenca. So on the vertical axis, we have the hashed routing key space. So like a float between 0 and 1, and then we have these like epochs in time on on the horizontal axis. And you can kind of see, maybe we start out with 2 segments as we hit epoch T1, traffic increases in 1 segment, so that segment splits into 2 segments. Same thing happens at T2 for the first segment. And then here at epoch T3, segments 2 and 5 sort of ramp down and merge. And then a stream is composed of what are your active segments, and your events sort of append, into each of these segments as according to how you're specifying routing. This is kind of what it looks like with a sort of simulated typical web traffic. As you see, with sort of moderate traffic, we have a lot of active segments. As traffic reduces, we see the segments merging according to an auto-scaling policy until at the lowest points of traffic we have, just 2 segments. And then as traffic ramps up again, the segments start splitting again to whatever the auto-scaling policy happens to be. You can auto-scale on sort of size of the segment or throughput. So what is Provenca really? This is maybe a more detailed look at under the covers. It's a tier 1 persistent log and stream cache. So this is down here, tier 1 storage, Apache Bookkeeper. We use Bookkeeper as a high throughput, distributed, durable write-ahead log. Now this write-ahead log, much like in typical journaled file systems, the log is used for recovery. So in this tier 1 storage, the data sort of lives in memory and it's acknowledged to the write-ahead log. And then the write-ahead log, should we lose this segment store that's holding this data in memory, the write-ahead log will be used to recover the state of the segment store. Additionally, there's a tier 2 long-term storage. We have pluggable adapters to S3, file system, NFS, HDFS, and more can be added. So as things, I guess, pile up in the segment stores, they are asynchronously transferred to long-term storage. So basically fast acknowledgements on tier 1 with efficient and transparent migration to long-term storage in tier 2. So this might be an object store. What this kind of allows you, if you think about, I'm just writing to an object store, I have to finish writing the entire object before I can go read that object. Well, with kind of Provenca in the middle, we can start reading the objects as, kind of as they're being written to the object store. It's maybe one way to think about what we're enabling. This is a much more detailed diagram, sort of showing the split between API and abstractions at the top and implementation at the bottom. What we provide in terms of abstractions is the main abstraction of a stream. On top of stream segments, we've also built key value tables and a state synchronizer. And then I guess down here in the client, we have quite a few different APIs and features in those APIs. The clients talk to a controller, which manages a lot of concerns in the cluster, and then the client also talks directly to the segment store. And it's a typical, I guess, source and sink type environment. If we're up here, we've got a lot of data sources using the system, and then data processors reading the system and possibly also producing more events. And so why did we build Provenca? Well, existing abstractions, whether like topics, queues, pub sub, they don't map really well to event streaming at scale. And some of these poorly suited abstractions, as they've evolved, enhancements have been sort of tacked on in an awkward fashion. And there's this conceptual mismatch negatively impacts both the computer programmer and the system administrator. If you've maybe ever tried to scale a Kafka cluster, you'll you'll see that. Just a quick breakdown of like, features and capabilities across maybe competing systems. We all have transactions, we all have event streams. Long-term retention is something, we kind of pioneered, but Pulsar has a long-term retention in the main branch now. And, maybe this should be a half circle for Kafka. I think long-term retention is coming. Confluent has it. I think the open source driver is HDFS only, and the proprietary Confluent driver is S3. So Kafka's, I guess, catching up or keeping current. But in terms of being durable by default, Pulsar and Provenca are durable by default. I think I've seen discussion about Kafka changing its defaults. I think there's a cap out there. Auto scaling, that's sort of where we see a lot of our need. It can be very complicated to auto scale or to manually scale these other clusters. Ingestion of large data such as video. So this really speaks to our byte stream primitive. You can, a single segment stream is effectively a byte stream or, a remote append mode file. So we use that, to do multimedia processing, digital signal processing on top of sort of multiple video streams. Kafka and Pulsar are doing this as well with packing buffers into messages, but we don't really, we have a pure byte stream. There aren't like segmented buffers. We're efficient at high partition counts as well as at high producer counts. I'll show that in the next slide. Consistent state replication, that's using the the guarantees of our segments to do the state replication, and then key value tables is a recent addition to Provenca. So this is just a couple of graphs showing as we increase, we're keeping, in both of these graphs, we're keeping throughput the same. In one graph, we're increasing the number of writers as we keep the throughput the same. So as we introduce more writers, they take a share of the aggregate throughput. And we can see how Provenca can maintain a consistent throughput rate as we add more writers. As well, Provenca can contain consistent throughput rates as we add more partitions, or as we call them, segments. We can see the other systems degrade as these factors are increased. And due to this sort of two-level batching that Provenca does in its segment stores is kind of where multiple writers can come in and get batched into a segment container. Segment containers are a level of batching for the segments themselves. That several segments will be in a single segment container. And it's this two-level batching that allows Provenca to achieve these results. We can see in this graph, in these graphs. This is just a really quick example of the API. This code assumes a writer, a reader, and this routing key path config. This is kind of an example of an exactly once stream to stream copying routine. Assuming the stream has JSON events, we begin a transaction in the writer. We tell the reader, we have the reader get the next event. If the event's not null, then we have something. If we've configured this routine to extract routing keys from the message, we'll go ahead and extract a routing key, and then you can see here we either write the event to a random segment, or we write the event to a specific segment according to routing key. And otherwise, we've got this concept of checkpoints. If the event is null, it's likely we have a checkpoint. At the checkpoint, we commit the writer. The checkpoint is initiated by the reader. It allows us to commit the writer and achieve nearly exactly once semantics here. There may be like small failure conditions here with these exceptions that could be, we could get to true exactly once with maybe some additional persistence on top of this. But just a really quick example, I guess, of a stream copying routine here. It kind of gives you the high level event stream API. And just some quick resources for Provenca. Our website's provenca.io. Our blog is at blog.provenca.io. We're on GitHub at github.com/provenca/provenca. That's the main server. We've got like 40 repositories for all kinds of other things. You can go to Slack or Provenca-slack-invite.heroku.app. Herokuapp.com and get an invite to our Slack. You can join our users mailing list, or check us out on Twitter at Provenca.io on Twitter. So that's kind of a, just a really high level introduction to what Provenca is. And then I guess I'll turn it over to Andrew to dig into what we've done with Provenca and Presto.
All right, thanks, Eric. Okay, yeah, hi everybody. My name is Andrew Robertson. Yeah, so I'm going to just briefly talk about the connector work that we did to hook up Presto with Provenca. So just quickly, I'm going to probably skip Derek gave a pretty good Provenca overview. I'm just going to get a couple, just hit the kind of key points in the connector and kind of show you where all the moving pieces are there. Talk a little bit about what's next for the connector itself, and then just a simple demo and code walkthrough. It's not a ton of code, but I think it just illustrates the various couple ways that you can use the connector with Provenca. So again, Derek spoke to Provenca, so and it's just a time. Let's kind of skip over that. Oops, I was expecting all that to come out at the same time. Yeah, so Provenca Schema, right? Obviously, schema is used to get a list of schemas and tables in Presto. For us, we do that by listing scopes and streams in Provenca. So it's a Provenca scope is basically a namespace, and then you can have uniquely named streams within that scope or namespace, right? So we have mapped that onto a Presto schema, a table within a schema, right? So when we get asked for a list of schemas, we're listing scopes from Provenca. And when we are asked for a list of tables in a schema, we're listing streams within that scope. So obviously you need, from there on, you need to have like an actual schema of the data that's stored. We currently support Avro, Protobuf, JSON, and delimited like CSV. And we support a couple of ways to actually get the schema, right? So you can either look it up from something called Schema Registry, which I'll touch on in a second, or you can have sort of things defined locally in a file on the coordinator. So the actual, so Schema Registry, there's an actual Provenca product called Schema Registry. And it's a first-class Provenca project. It's general purpose, but as you might imagine, has a lot of integration with Provenca itself, right? So it gives you serializers and deserializers, has some client libraries that you can hook up to your Provenca client, and it'll manage your schemas for you, right? If that's what you want to do. So it'll take care of storing the schemas, managing them, validating them, and kind of versioning them and tracking evolution as you go on. You don't have to use that, but if it's configured for us, basically we're looking by convention for an object called a group in Schema Registry, and it's scope.stream. So we will look for something in Schema Registry called scope.stream. If it's there, we'll use the schema that's defined there. The next is you can have things in a local file. So just on the coordinator, it's one file per object, and basically you're either just inlining the event definition right there in JSON format, or just an example here, you can just point to like an Avro schema, right? So basically saying, my schema is HR, the table name is I want it to show up in Presto, it's called employee, and object name is the stream on the Provenca side, right? So we'll look for HR.employee within Provenca and read from there, and we will use the schemas defined there. Presto table description supplier class for us is kind of the main driver of the metadata for Presto. This is where we do all the mapping, the looking up from Provenca for the scopes and streams, and looking up for schemas, right? So we just talked about either we're going to have a local file for our schema, or we're going to check schema registry, right? So that's kind of the order we do. If we find something locally, we'll use that schema. Else we'll look in the schema registry if it's configured, right? And then at that point, we're just mapping, for example, like the fields in your Avro definition to Presto table definition. The other thing it supports too is being able to query multiple streams at once. Like a lot of times, in Provenca, you may have a lot of streams that are kind of doing similar things, maybe from different kind of sources. So if you had streams that are same type, sensor 0 through sensor whatever, sensor n, you can set that up to query them all as a single table, and it does the caching of schemas and table definitions. Okay, so more interesting stuff. So defining splits, right? So basically, I mean, as folks I'm sure aware, right? The splits is how the workload kind of gets split up and spread amongst all the workers, right? So for us, we kind of have two stories. We have what we have now, and then what's coming, right? So our parallelization is basically at the segment level. So as Derek said, right, a stream is maybe made up of multiple segments. And that's what right now we're kind of locked into as far as concurrency. So if you have 16 segments, then we have 16 splits, each one reading a segment, right? And you can imagine that if a stream is very large or has a small number of segments, right, then we have kind of wasted power. And the issue for us there is we can't, and by we, I mean like a client application of Provenca, it's kind of hard to find an event boundary. So we can't break up a segment at some arbitrary place in a stream, right? We don't actually have that information. One thing we can use is something called the stream cut, which is just notes of position within a stream across all the segments. So you can, at this point, if you have knowledge of a stream cut, you can use that to find these event boundaries. And now instead of one split per segment, right now we can have the number of segments times the number of stream cuts that you have. So what we have now is an out-of-band way to store the stream cut information. So this would be a client application, just when they're writing their normal stream, every once in a while, maybe they'll persist a stream cut. Maybe this is after some number of events. Maybe this is after some number of megabytes of data that they've written, right? And then we'll read this specially named stream and use that stream cut information to kind of split things up. So that's what we have now. It's not optimal, and it's not going to be the final solution. But stream cuts is the way that we're going to be able to actually split up work for us. So just briefly on processing splits. So a split is going to end up with something called a segment range, and all this is basically just a start and end offset for a specific segment in a stream. So some number of events contained within this raw segment range. We're reading raw event bytes. So if you see on below, we use this thing called the batch client API. So Derek talked about how Provenca, there's like a lot of ordering and time guarantees and all that stuff when you read it, right? Well, using the batch client API, we can actually read the segments just as events as raw byte buffers, right? So we give up all the time ordering and all those sort of ordering guarantees for the ability to query things in parallel, right? And ordering doesn't necessarily mean as much for us because you can, the query can order it how it wants. So we're basically just reading these raw byte buffers and turning them to some sort of readable events, and we're setting up all the normal sort of Presto conventions for extracting fields, right? So we end up with a list of field value providers where then Presto can ask us for a value for a field in a row. So actually getting raw bytes into a readable object or a constructed object depends on how data is written. So as I mentioned that there's Schema Registry support. If you use Schema Registry, if Schema Registry client libraries itself are going to serialize the data for you. It's going to put a little bit of encoding information inline in the events so that when you read it out, again, using this schema registry libraries, it can look up the schema, it'll cache the schema locally, and it'll construct your object and give it back to you, right? Or you can just have a schema registry unaware client and just write raw bytes. So we basically need to know which that is, otherwise the parsing will fail because there's just, to us, arbitrary encoding info in the events. So we're basically just either configuring a deserializer that uses schema registry, or we're creating our own, right? But the end result is using a deserializer to give us the object back. And then, right, so when we're actually doing it, right, our record cursor is just basically using the bash client read segment. Read segment is just giving us some iterator to the events in the segment. And it's as simple as just, getting next byte buffer until you get to the result set. We're using one of those two ways of deserializing. And then we build our row decoders from there. And then we're able to give the fields back when asked. So that's what we have now. Future work is we're really going to focus on query performance. I think at this point we've just got something up and running, which works, right? But the next step is to make it work really well. First and foremost is to create, do a better job of creating splits, right? So we already kind of have an idea of how we can do it. We have a POC to do it, to get splits of an basically arbitrary user-defined size. We can break things up, right? So we can get rid of that out of band, persisting extreme cuts to make it seamless to an end user. And then a user in their query can set a session property, a little slider of how big they want their splits, and we can make that happen. So like I said, there's not just using existing stream metadata within Provenca. We have a POC for it and it's coming. And then, following all that is getting it production ready, right? It's not production ready now, but we're taking it there. So all kind of help or comments or anything in the community, would be great and be much much appreciated. But yeah, that's where we're headed. So I did have, I don't know how we're doing on time. I just kind of wanted to, I already ran the demo. So just going to quickly show it. And I just kind of wanted to show a couple of code snippets. So I was going to go ahead and do that. I don't know if anybody has any questions in the meantime.
In terms of time, the next presenter, Costin, will take 10 minutes. So
10 minutes?
I think you have time. Yeah.
Okay. All right, cool. All right, well, let me go ahead and if I can remember my password. Okay, so we have the first thing I think to mention, right? So we have our GitHub and our connector is under the Provenca org. And the first thing I guess just to point out is that and maybe this actually feeds well into the next one, but our code is maybe obvious to some, but it's not in the mainline Git for Presto DB, right? So it's under our own org. So our code, excuse me, is just compiled and built separately, right? So that's what we have here. So this is just our code, and we pull in everything as dependencies. So that's a sort of first thing to note. And then we have a little getting started. So just underneath there, getting started, we have a little demo. It's basically, you just bring up the stack, right? And the stack being Provenca itself, right? So brings up Bookkeeper, Zookeeper, Provenca, Provenca Schema Registry, brings that all up. It brings up a Presto DB image with our connector loaded onto it. And then you can run the sample code and ingest some data. So I already built an image, right? So our connector is not on there. So I just pulled an image and loaded our connector and copied our configs into the image. So that's already built locally and running. We don't publish anything right now. So that's what you have to do. You have to build our connector code, load the tarball, the plugin onto an existing Presto image, and then start it up. So I mentioned I've already done this. The things are up and running. Just takes a minute or two. It builds and ingests the data. Nothing too exciting to actually see on the screen other than I just write 1,000 events of a couple of different types, right? And basically just shows the schemas that's stored in Schema Registry. Again, schema is showed in Schema Registry, and you'll notice the last one doesn't show any schema, and I'll talk about it in a second. So nothing terribly exciting there. So in this little code, so there's basically three things it's showing, or 4 things it's showing, I guess. There's 3 different ways that we're writing data. So the first one is it's like our client is very tightly integrated with Schema Registry, right? So in this case, we're creating a Schema Registry, a serializer that uses Schema Registry, right? So we're adding our group. I mentioned our naming format is scope.stream. We're saying, okay, here's my configuration, which is basically just the IP address of the Schema Registry itself. I want you to take care of managing schemas for me. And then I create a serializer based on the actual object that I want to do, right? So this is a Schema Registry provided serializer, right? And then we're using that. The second case is we're serializing things ourselves, right? I mean, the client application, but we're managing our schemas in Schema Registry, but we're not doing it in an automatic way. So I'm still adding my Schema Registry group. I'm telling it it's JSON. And here I'm explicitly adding the schema, right? So in this case, we're writing, the event that's written to Provenca does not contain any sort of metadata or encoding info. And I just have some, just basic serializer that I've made myself, right? So that's externally managed. And then the third way is we're not using Schema Registry at all, right? So I just have that same simple serializer, and I'm not putting schema anywhere. And then also in this app is just gives a little supplier, right? I mean, as you can see, I wrote 1,000 events of each, and it's just creating some dummy data, right? And it's giving that to the Provenca writer to actually write. So on that last case, right, is this simple object called transaction. And this is one where the schema is not managed anywhere. And then this is where right, they've defined the schema file locally on the coordinator, right? So this demo, right? So my scope is demo, my stream is transactions, and then this is the field event, the field table definition inline, right? And then this is loaded onto the image for the coordinator to find, and our metadata component to find. So those are the 3 ways, and then all we do is just give it to just a generic method to insert the data, right? So this is the actual writing to Provenca. This doesn't know about Schema Registry, it doesn't know about Presto or anything, just creating your scope for you, creating your stream for you, and then you creating a writer with your objects type, right? It's just getting the data from our little dummy suppliers there, right? So we're just inserting our dummy data, and we're writing events. So the first part is the routing key, right? So you can use a routing key, and this is what distributes your objects across the segments within a stream. That you may key off of some piece of data in your object or something. For us, this is all just dummy data, test data. So we're basically just, by doing this, we're just basically try to spread things around more or less evenly. I've set up this thing called scaling policy, which I'm saying I want a fixed number of segments. There's 10 segments. So we're just basically writing these 1,000 events evenly across the 10 segments. And then that's it, right? So this is completely unaware of Schema Registry or schema or Presto or anything like that. So now at this point, the data, like I said, I already ran this. The data is in Provenca. So I'm just going to open the CLI, right? I'll go through this quickly because I'm sure most folks are intimately aware. Right, so again, show schemas from Provenca. At this point, we're listing scopes from Provenca, right? And we have demo, show tables. Right now I'm listing streams within the Provenca scope called demo. So just I'm describing inventory, right? Inventory was one of the ones that managed Schema Registry. So at this point, I'm pulling that from Schema Registry, right? And then right, transactions was the one that's locally defined, and you see that here. And then you can just dummy data here, right? But you can run your query, and it'll give you results. And then I just wanted to show quickly, and that's not readable. Right, so you can see all this was just looking up groups just externally to Schema Registry, right? You can see that there's more than this, but you can see how in my groups I have something called demo.sensor, demo.inventory, right? And then I can use the Schema Registry REST API, to actually drill down and get those schemas, right? So that's how it's kind of all working together. So yeah, that's all I had prepared to show. Just kind of want to open up for questions about this or anything in Provenca.
I think this is
Okay.
very interesting. Thanks for the presentation. I had just a few sort of questions just to help clarify my understanding.
Yeah.
So the stream cut concept, is this essentially a way from the client in the client side to sort of inform whoever's ingesting the data that this is a logical boundary of data, or I guess ignoring Presto,
Yeah.
what is the concept of stream cut, I guess?
Yeah, so stream cut is very much what the client application, so the application that's using Provenca wants it to be, right? So maybe when you're writing data, maybe you're writing data hourly. So you're at 1 hour, you're persisting a stream cut, right? And then you can kind of use that stream cut and logically map it to something with meaning, right? So you can say, okay, I logged a stream cut at this position in the stream at 11 o'clock in the morning on October 5th, right? And that where your data from October 5th at 11 a.m., right? It starts there. So it's really it's really up to the client, right? There's is what gives it meaning. So it's up to you how you want to use it in your application.
Gotcha.
Yeah, or in the stream to stream copying code sample I showed, the stream cuts would occur at the checkpoint times. So in the reader client I showed, by default checkpoints happen every 30 seconds. With an interval-based checkpoint, you're basically getting random offsets inside each segment. If we're talking Kafka terms, a stream cut would be the total collection of all topic partitions and offsets within those partitions for whatever your current position is, or for prior positions you've recorded.
Got it. And it sounds like typically a stream cut at worst would happen whenever a checkpoint happens, but it could potentially happen more frequently as well.
Yeah, correct. And yeah, checkpoints can be manually initiated as well. Or
where's the checkpoint?
Go for it.
Sorry, I was going to ask, where's the checkpoint persisted?
In readers, you have a reader group, so much like a consumer group. The reader groups are backed by a state synchronizer metadata stream. And so readers will coordinate over this state synchronizer to initiate these checkpoints. Every checkpoint will be recorded to the reader group metadata stream. It's so you can go there. Those streams are kind of pruned or truncated automatically, but you can find most recent checkpoints and prior checkpoints in those metadata streams. You can also take the stream cuts and save them off at your own locations. We don't. The stream cuts are a little bit obfuscated behind a base 64 string, But if you decode it and look in there, you'll see like segment numbers and offsets. And we need to improve our stream cut handling to target, Druid or other systems where they want to natively know, each segment number and each offset number.
Thanks.
And then it sounds like the proposed enhancement that you had mentioned to automate the split size, just to clarify my understanding around that, it sounds like that would be, you would not be relying on the client side stream cut. Instead, you would be sort of like automatically grouping together a bunch of these stream cuts until they hit a target size. And this would be called a split, just so that, a system like Presto, like you're giving information to the client to target a system like Presto so that they can efficiently, sort of like,
Yeah. So yeah, exactly. So I mean, what Derek just said at the end, right? So actually being able to get start offsets within a segment, right, is the key. Because right now, there's no way to find an event boundary for us, right? So there's this concept called watermarking in Provenca, which basically is just internally, more or less taking a stream cut internally. And this is to help, when readers are, there's multiple readers in a reader group reading that data out. It's basically a way to let that all readers have passed a certain point within a stream, and that anything before that has been processed, right? So we can use that. It's internal to Provenca, so we can use that stream, and that gives us stream cuts, right? So we can use that in order to more or less get our arbitrary size of a split. But really, what we're after is just being able to find those event boundaries. So that's our first kind of proposed way, is to use some internal metadata from this watermark concept.
Maybe just one clarifying point. Offsets in Kafka are the message boundaries. Offsets in Provenca are bytes or byte offsets. Everything in Provenca is a byte stream. Yeah. Events, when you're writing events, we do put a tiny little length header, but that's about all we add to your data. And so I guess, maybe to Andrew's point as well, in order to improve some of this, we could maybe look at keeping event boundary indexes or so on.
Sounds good. Any other questions? I had one other question, which is like the available serialization formats. It sounds like what they all have in common is they don't store, sort of like putting out the limitation of streaming storage in general, but like the commonality between all of them is that they don't hold statistics, or like, sort of like file statistics. So I remember Avro and JSON, and I forget some of the others, but essentially like the idea is in theory, any type of format where it could be represented as a list and doesn't have summary statistics, could be a suitable format in the future.
Yeah, so we can, right. Well, so I mean, the first thing maybe I should say, maybe not exactly to your question, is, so I just wanted to clear up. So Provenca, you can store anything you want, right? So Provenca proper, you can store anything, right? It's not limited to Avro, JSON, protobuf, or just strings, right? So that's just us. The reason why the connector starts with that is just because that's what Schema Registry sort of supports natively, right? So it has serializers and deserializers for things like that. So that's how we ended up where we are. But we could support lots of types as long as we could be able to pull in the schema. And it's obviously easier with these formats. Gotcha. Yeah. But there's no limitations in Provenca. I mean, it's store whatever you want in there, right? It's just more on the connector side.
Any other questions? All right, thanks a lot, Andrew and Derek and everyone at the Provenca team. It was very it was very interesting to learn about Provenca, and definitely, you know, like to hear more about the Provenca connector, and you know, like see more usage from that.
Yeah, thanks everyone for your time.
Yeah, thanks for having us.
All right, next is Costin. Is Costin here?
Yes. Hi. Okay, let me. Hello, everybody. Can you hear me, Tim? Sorry. Okay.
I can hear you.
Good. I don't have much to present. Sorry, I've been a little bit in a hurry, and we are ever busy in Facebook. I have a document that I shared earlier on the mailing list. Let me, for the purpose of not being just a talking head, I'll share the screen to the document. The TLDR of it is that the way we are currently building Presto is unsustainable. You might have noticed if you downloaded the sources and you run a MVN package or MVN install or something on your local desktop, you might have had some tests failing, and you may have currently, it's quite convenient to exclude some projects from the build. And you may be wondering, how are we doing it so that every 2 weeks or so we publish a new version of Presto to central Maven repositories and so on. So we in Facebook are the guilty parties and responsible parties for publishing official Presto releases, right? And the current structure of the project creates quite a little bit of problem for us, and no wins either for us or the user or the community at large. So the problems are twofold. One is the build times. The build times are humongous. Then we create very big artifacts by open source or Maven ecosystem standard, like our Presto server is currently at 1.1 gigabytes of various jars and zips with all the plugins. And on the other hand, we kind of have an implied proposal to the community that this official Presto distribution, when it comes out of Facebook, it will come with everything nicely well tested and well rounded. And the truth of the matter is that some things are tested better than others. In particular, our internal release process at Facebook, we kind of test heavily on a typical data warehouse workload that reflects what our needs in Facebook. So given that, the core engine itself and the connectors such as Hive are much better tested than other connectors that obviously we don't test as much. And in particular, lately, there is a connector that we don't test at all because we can't. I'm talking about the Prometheus connector. And there are other connectors, I won't name names, that we still test during the release process, but probably we shouldn't. And it would be better if we don't test it at all. So the proposed change would be to separate all the connectors in separate projects. At least the minimum we absolutely have to do is separate the build and release process. So I prototype a little bit to see how difficult it would be difficult at all. But before we commit this thing, we need to, before we commit to exploring this direction, we need to decide that, okay, it's a direction it's worth going into, and resolve a little bit of open questions, which is especially with regards to versioning, like currently, there's a big advantage to the status quo, which I highlighted here, which is like, okay, everybody has a batteries included solution, including the little lie that various connectors are nicely tested with the whole part, where in reality is the degree of confidence you can have in different connectors varies wildly. And so it would be more honest to our users to keep connectors in separate projects. And if we do that, then we have the problem, how do we put them back together in a way that provides most convenience to our users and meets their expectations. So that's the TLDR of it, and I think my questions to the steering committee is if this is a direction that we want to go to, and obviously the document is just a very initial draft. I'd like I didn't receive much or any comments at all, so I don't know if it's silent implies okay consent or silent implies okay that's not worth discussing. But it's not out of ordinary. There are other communities who have a similar approach, like the Kafka is an example where MongoDB connector is issued separately by MongoDB itself, and there's many other examples in the wild. So that's yeah, that's my short presentation. And the first card, I would like things like Presto Prometheus. I should have added here. That has a little problem because it requires that the system that does the testing have Docker installed and Docker with access to the Docker repository, which is quite a big assumption to make. We cannot support inside our current release process in Facebook.
So I think to your question of like what does the silence imply? To me, that implies lazy consensus.
Okay.
So I would present the question to the entire group, which is anyone does anyone disagree with moving at least the less frequently used connectors to separate repositories within the Presto organization in GitHub?
So I'm like, I get that these are like two sides of, I don't know, some coin, and it seems like there's some complexity on one end when these things aren't in the same repository and version together. Like you have to go build multiple things at a time when you're doing development, and we're running less testing. So like someone lands something to a connector, they land something to core, you may not notice the connector is broken because you're in theory not running the tests. Like it's not really a clear free lunch here, at least in my mind.
Yes, that's correct. On the other hand, there's a matter of fact that, for example, Presto Prometheus is not tested, so we don't know if it works, but we are releasing it for the time being. Mm-hmm. Also, some less well-maintained connectors, or by judging by the history of commits and by the quality of the tests that we run during the build release process, I don't have much confidence, right?
Okay, so. Like especially if we're talking about like a subset of things that like fall into this category, it sounds great. But if this is something that we can solve by throwing machine time at it, like if there's an issue with the responsiveness of our tests, you know, I just don't want to take this too far. Like I wouldn't want to unbundle everything, I think, and not, or if we unbundle them, we'd still kind of want to run the tests on every commit on changes to core Presto. So like there's a limit of how much we can get without like sacrificing, I think, like responsiveness for our changes.
That's correct. Another mechanism would be to have metadata associated with connectors, where you know, we tell the user what's the version range that the connector has been tested with, if a connector lives in a separate repository. Mm-hmm. Right. So for example, currently Presto Prometheus cannot cannot be tested during our, our current release mechanism, where Facebook takes responsibility of producing the Maven package, the official Maven package, right? And the workaround has been, okay, the Presto Prometheus wants to run Docker during tests, we'll skip that. And then a user who downloads Presto trusts that, okay, Presto Prometheus, likely it's working, which, yeah, there's a reasonable chance of that, but we haven't run the tests. And
I think there, sorry, this is wrong. And I think there is a more fundamental issue than whether to move connectors to a separate repo here, which is how do we as a community do releases, right? Like, I think the thing that really doesn't scale is Facebook do releases for everything. And that is the fundamental problem we need to solve. I think like moving connectors would help to say that, okay, this is what we verified and we have confidence, and the rest of the things that we didn't verify, this we don't have confidence. So, use at your own risk or something. So, but like, I think fundamentally we need to get into the details of how to execute, and the real problem we need to discuss is also like how do we do releases going forward. Does that make sense? Or like, I think generally I agree with this approach on the direction, but I think there's a lot of details that need to be sorted out. We also don't want to be in a situation that, we move some connectors out and it doesn't even build anymore over time. Yeah.
I think it's definitely a question that we have to discuss. And it's personally also been on my mind, which is there's a number of deficiencies with our current release cycle. The first is that it's not realistic. Like the current cadence of releases is fine, because it's fine if you're looking for bleeding edge functionality. Whatever comes out sort of like within merge, or whatever has been merged, is actually becomes available only a few weeks later. But the release infrastructure and quality, like for a system like Presto, it's sort of like a never-ending project. And it's very ambitious to expect 100% perfect quality every 2 weeks. And so I think that this project should look for other examples from the open source community about how to release these types of complex distributed systems, or these complex code bases in a way that better shares to the community the sort of level of confidence of the release. And sort of like one example is Ubuntu style releases, which is very manually, sort of like very labor intensive, but they do sort of allow you to pick your own risk tolerance in terms of sort of like bleeding edge technology, or bleeding edge updates that come out very, very quickly after merge, which would be unstable. Regular updates that happen less frequently, which would be LTS, and then maintenance release for legacy projects, legacy code bases, where the companies involved don't have the labor to continuously update their Presto distribution. And I think it would be beneficial to the community to provide these options, or similar options, maybe not exactly in that model. And I think going forward, as we think about conformance and the conformance program, and sort of like providing a program for vendors to certify that they are Presto compliant, I think that it will also be important for that aspect, because it will be very difficult for a Presto conformant distribution to certify themselves every 2 weeks. And this would also sort of like give them a mechanism to, target a more stable, less frequent release cadence. And these longer term releases, I think, are something where, the community can much more, sort of like easily help out with that aspect, and sort of like, get involved with that level of testing, since, like typically this implies any feature that goes into longer term releases has had some time period to bake in some sort of unstable branch, or, sort of like more frequent branches. And the features that go into these longer term releases are, sort of opted in and more selective. So I definitely think that, this is a good topic for us to discuss further, and probably something that we need to tackle. So I 100% agree on that. That being said, sort of like this refactoring out of connectors, I think it's also like both Costin and Ariel and Wrong made really great points here, which is that, and I think my takeaway from this is that we don't want to go overboard. We probably don't want to move out all connectors, but there's probably a bunch of them that we can look into where we can find ownership, and then provide a mechanism where we can include it with the default Presto distribution with some level of testing, probably equivalent to the level of testing that we have now.
There might also be opportunity to beta some of this with, projects like us. I think we would like to eventually propose our connector for inclusion in the Presto distribution.
Right, and we do have a pilot program right now, and you're definitely more than welcome to join this pilot program. Sort of like we're starting with Alibaba, and we'll also be happy to start with you about giving you a dedicated space within the Presto organization where you can donate your code as and then we can package this with the main Presto distribution, along with default, like a level of testing that gives us, like assurance that, equivalent to other connectors into an integration test, and, like some level of quality.
Yeah, sure. So I'll follow up on that as time goes on.
Sounds great. I think we're a few minutes over. I think if you're interested in sort of like discussing the details of this, let's keep it onto the email that Costin sent. I'll bump it up to the top of the mailing list, just once again, so that we can get some offline discussion. But I think that there's kind of like a middle ground in between, sort of, like that takes into account both Ariel and Costin's points. And if you feel strongly in one direction or the other, please feel free to bump it up to the top of that email that Costin sent. Okay, we're actually over time. Is there anything else that someone wanted to bring up really quick? All right, thanks everyone for joining. Thank you.